Hello everyone, and welcome to a very short discussion of a slightly different way to approach the idea of energy and the law of conservation of energy, and that's by confining ourselves to something which the AP people call total mechanical energy, TME for short. Total mechanical energy is simply the sum of the kinetic and the potential energies. So you can calculate your total mechanical energy by summing up your kinetic and then your gravitational potential and your elastic potential if you have them. Now notice this is mechanical energy, so we're only talking about mechanical potential energies. We're not talking about things like chemical potential energy or nuclear potential energy. These are just the mechanical potential energies plus your kinetic energy. Right? Notice, we're not talking about work, we're not talking about dissipated energy, which is why this is different than the approach we take. I personally like our approach, but I need to introduce you to this in case you see it on an AP test. Now, when looking at something from the terms of its total mechanical energy, okay, one of three things is going to occur if something is moving. First of all, so a system's total mechanical energy could be conserved, which remember means that it would stay the same, only if two things are true. Only if there's no energy being dissipated, which means there's no friction, and there's no work being done. That means there's no energy being transferred in or out of the system by, of course, external forces. So as it says here, that means if it's frictionless and isolated, then your total amount of mechanical energy is the same. So think about, for example, a pendulum, a perfect, ideal pendulum going back and forth forever. That pendulum might have more kinetic at one point, more gravitational at another point, but the total amount of mechanical energy would stay the same all the time because there's no energy being dissipated and there's no outside forces doing work on the system. Now, if there is friction, then energy will be dissipated, right? We call E-dis, and that means your total mechanical energy will change. In fact, it will decrease, right? Because some of that mechanical energy will now get stored as things like thermal energy, light, sound, all those kinds of things that are no longer useful to the mechanical system. So again, if we have a pendulum, but it's a real pendulum, and as time goes on, because of the rubbing that goes on with the string, say, and the clamp, or because of air resistance, right, we're going to dissipate energy, and it'll slow down, not go as high, and eventually even stop. On the other hand, if we reach in and smack it every once in a while, then we're exerting an external force, and external forces do work on the system. And when you apply or do work on a system, you will change its total mechanical energy. Positive work will increase the total mechanical energy. You're adding energy into the system. Negative work would take energy out of the system. So maybe you have something that's moving and you push against it, slowing it down. Right? Now you're taking mechanical energy out of the system, right, doing negative work, and decreasing the total mechanical energy. So again, I prefer to look at our systems as big, inclusive things with E-dis inside, but unfortunately the AP test sometimes will look at this from a mechanical energy standpoint. So it's important that when you see that, you understand that they're not talking about dissipated, and they're not talking about work. They're talking about the sum of the kinetic and the potential energies. And we're going to practice looking at things a little bit on the next worksheet. Thank you, and I hope you enjoyed this discussion of total mechanical energy.